The next technology advance is the compact disc. Um, Compact discs are different from um, audio tape recording and records in one main aspect. Um, Tapes and records, they can be classified more into the mechanical side of recording, whereas compact discs tend to be more into, or are more in, the electrical side. That is, the mechanical side, records and audio tape. There has to be a point of contact. There has to actually be physical contact between the arm of the turntable or the arm of the phonograph or the record player and the record. With the audio tape, what has to happen is there has to be physical contact between the tapes and the recording heads. That's how the recordings are made. With compact discs, it's more, there is no physical contact. In fact, what actually happens is compact discs are made up of lines of data, binary data, that is zeros and ones, what computers use to, as far as data is concerned. And what reads that data on each compact disc or each line of a compact disc is a light. A laser reads all that data. So there is no real physical contact. You have a laser that reads the data that's on there. Where there is a 0, there is no data. Where there is a 1, there are digital words, and those digital words become sounds that we hear from the compact disc. This is what you get when you buy a compact disc. You're in the basically what's known as the CDA format. So there is no physical contact. Rather, it's just light. That means that there is no wear between on the CD. When the needle hits that groove on a record, that's physical contact. That means there's going to be, the more that there is contact between the needle and the record, the more wear there's going to be on that groove, and the more wear there's going to be on that needle. With audio tape, the more that audio tape runs across those heads, the more wear there is on the audio tape, but also you get what are called head clogs on the heads. Eventually, those little metal particles tend to loosen up and actually congregate on the heads, and so heads have to be cleaned to take all that residue off. Otherwise, you get muffled sound, or you don't get any sound at all. That doesn't happen with a CD. There is no, the lasers can get dirty eventually, but for the most part, there is no wear on the CD, and there is no wear on. So what this means is, as far as the technical effect in looking at the two effects here, that means that the quality of the sound is going to last much longer on a CD than it would on an audio tape or on a record. The wear just doesn't exist on a CD. Certainly you can abuse the CD in many different ways, and that can have some sort of an effect on the sound quality. If you spill something on it, it will affect the light. But at the same time, you can clean that stuff off and the sound quality returns to normal. So CDs are in the electrical area. That is, that there is no physical contact between the light and the CD itself. As far as the consumer effect, much like audio tapes, you have a much more flexibility as far as listening by the audience member, because CD players are programmable. You can tell the CD player to play specific tracks on the CD, and that's all it will play. And then once recordable CDs became available, you could do much like the with audio tape, you could have a compilation CD. You can take your favorite songs or favorite recordings from a bunch of CDs and put them onto one CD, and now you can have basically a compilation CD drive. What's interesting about CD technology is that this was really the only media technology where there wasn't a format war. For some reason, the manufacturers, the recording labels, the technicians, the computer technicians, everybody who's going to be involved in the making of CDs got together and decided what sort of format they were going to have, and that's the one everybody took. Unlike the different record formats, unlike what we'll find in television, the different video recording formats, CDs didn't have to go through that. They just were, everybody agreed what the format would be, and that's what you'll find pretty much everywhere in the world. The last type of technology, which kind of brings us up to today where we are, is computer file compression. To understand really how compression works, we have to understand how computer files are made. When you take a whether it's a CD or you're recording off a turntable, off a record, or from a tape, when you are recording into a computer, when you are creating an audio file, what you are doing is, what the software is doing is it is taking all of the sounds that are on that original recording or during whatever equipment you might be using to record a live performance. All of the sounds are put into the file and turned into data. These complete files are what are known as WAV files, WAV files. These files, because it has all of this data from all of the sounds that are being captured, can be relatively big. A WAV file for about a 3 to 4 minute song could be somewhere between 40 and 50 megabytes. That's still a relatively big size to try and move from one place to another on the internet. It can take some time to do that. And what companies were looking for is a way to make these files much smaller. What sound engineers found, and sound engineers prefer WAV files because they like to have all the data there because it's much easier to deal with all the data. What they found is that, and see how this compression works, we have to understand that we as humans, even though there's all this data in this file, all this music data, all these sounds in this file, we as humans can only hear the loudest sounds. So there may be data related to the percussion section that is very loud. You may have a timpani making loud sounds. You may have drums making loud sounds. But you also may have a very quiet violin, or you may have a very quiet piccolo, or some other instrument that's much quieter, or a harp. If those two are playing at the same time, we as humans, our human ears only hear the loud sounds, hear the percussion sounds. But that harp sound, that harp data, is still in the file. So it takes up space. So what engineers determined is that if you get rid of the sounds that are taking up space there, the data related to those sounds that we don't hear, you can reduce the file of the size, and as much as down to 1/10 of what the original file was. So if you have a lot of data in an original WAV file and you get rid of that data, and that WAV file was 40 or 50 megabytes, you could break that down to 4 or 5 megabytes. And this is what the MP3 technology is. It's just getting rid of sounds that are in a computer file, an audio computer file, that we as humans don't hear anyway, simply because the softer sound is being drowned out by the loud sound. We only hear the loud sound. Get rid of that data related to the soft sounds, and now the file is much smaller. That's really what the MP3 format is. Apple, of course, has its iPod. Sony had its own version of MP3. A couple of other recording technology companies had their own type of MP3 format. Eventually, they all came to the point where everybody only wants to listen to MP3 format. So iPod eventually changed its capabilities to not only have iTunes, but you could also play MP3 formats on it as well. And that's pretty much nowadays what you see on telephones or cell phones or other places. Any kind of MP3 player that you might have is playing that compressed, smaller file because that's what the audience, what the consumer is wanting. What are the effects of the computer file compression format? First, the technical effect is that it's much easier to transmit these files. They go much more quickly. In the early days of music file transmission, when Napster was king of the internet, it could take hours just to download one 40 megabyte file. But as more and more files were turned into MP3 files, that became much faster. Certainly, it was also the fact that the internet became a much faster vehicle as well, a much faster conduit. But because what also helped is the fact that MP3 really became kind of the format of choice for consumers, simply because it was easier to move from one place to another. Just moving from your computer onto your MP3 player, it was much faster to put a bunch of files on than it was to put the WAV format files on. As far as the consumer effect, this made more room available. When you have this file that you're using is going to take up relatively little space, you can put so much more of those files that you want, and primarily they were music files, onto your player to carry it around from one place to another. You can put your whole library on some players. Certainly nowadays, of course, with record companies finding that they, and we'll get into this a little bit when we talk about issues, record companies first didn't recognize this format and really didn't kind of recognize the computer file technology at all, and now they're right in the middle of it. If you want to download a song, it probably takes you about 30 seconds. Or you can, what they want you to do actually is to come to their libraries, play from their libraries, so that they can keep track of what music is popular nowadays. So it's easily transmittable, and you can download it very quickly and have much more space available for many more files.